So this is one of the relations which is generally being used. I is equal to IB plus IC, and these are the two junctions here, right? And it depends, junction depends upon this, these voltages. Okay, and this is the energy band diagram for NPN transistor in its active region. Active region we know, emitter base junction forward wise and base collector junction reverse wise. This nomenclature you should know कैसे होता है. Okay, so this means at higher potential, this means at lower potential. That's why it is equal to VE minus VB. This is one of the few things which you must be aware of. Okay, then we discussed about this. This is also important. This one. Okay, anyway, so I think NPN and PNP both we have discussed, I think. Now, next is transistor current component. Suppose this is P, this is N, this is P. This is reverse bias. All right. So this is we know this is current IE, and this is current IC, and this is current I. Sorry, it should be opposite. So this emitter current, because one is because of this, because of the holes, and another one is because of the electrons. So when we apply this negative, okay, okay, this is forward wise here. This should be forward wise because we are going to operate in the active region. This is reverse bias. Fine. A forward bias है, a reverse bias. So if this is positive, holes will be repelled. Okay, and electrons will be holes will be repelled towards this side. Okay, and electrons from here will be attracted towards this side. That's why this current is because of electrons and this current is because of holes. So IE is nothing but holes from emitter to base plus IEA electrons from base to emitter. Right? So both the this electron movement is opposite. That's why it is in the same direction. So if you see, this is nothing but this is a minority carrier here. Currently because of the minority carrier. And opposite is true for NPN transistor. Okay. So these holes which are moving towards the collector, they all are not reaching there. Some of them they are going to recombine with electrons here. अगर यहाँ electrons होंगे, so this hole is 5% of them they are going to recombine at this place. Okay. So if we talk about this is IHC because of the holes. And we have to find out this current. So this is because of, so 5% of electrons here, holes here, they are going to recombine here. So 5 electrons must enter into this, and this is going to be the base current. And there is one more current, which is because this is negative, so it is going to attract the holes from here also to this, right? So collector current is this is because of the minority carriers. So this ICO. So ICO current is because of holes and because of electrons. This current is holes from base to collector. This is from electron from collector to base. This current is okay. So electron here is minority and holes here is minority. That's why if you see this current, so this hole is minority from base to collector. Moving towards this side, so current is opposite to that. So इलेक्ट्रॉन माइनॉरिटी हो गए दिस कलेक्टर में एंड बेस में माइनॉरिटी हो गए. सो बेस में माइनॉरिटी हैं होल्स और कलेक्टर में माइनॉरिटी हैं इलेक्ट्रॉन्स. बट दिस करंट इज ऑल्सो कॉल्ड एज लीकेज करंट एक तरह से. ओके और माइनॉरिटी करंट ICO means this is the current when the emitter base junction is open circuit. Okay, that's why that is what it means. So this right, this collector current, if you see, this collector current, if you see, it is this collector current. यहाँ से होल करंट है. If you see, IHC is nothing but, or IHE is 100, IHB is 5%, and IHC is 95%. So this IHC is nothing but equal to alpha of IHE. Okay, or we say IC is equal to alpha IE. The value of this alpha is amplification factor its value ranges from 0.9 to like this 0.95 to 97 like this. That is approximately equal to 1 एक तरह से. Okay, so means IC 95% है IE का. Okay, where we are neglecting these minority currents, इस केस में हम थोड़ा सा इनको नेग्लेक्ट कर देते हैं because they are in nano amperes. Okay, so this equation is, you can say IC is nothing but alpha of IE plus ICO. We can neglect this ICO because ICO is the current because of minority carriers. Okay, or in the nutshell we can say IC is equal to IE plus IB. वैसे बात है, सॉरी उल्टा है. Right, so these are some current equations, these are the current components you can see. So if you see, we have current components, this is 1 2 or this is 3 and this is 4 and this is 5. 5 current component एक तरह से. Any questions regarding this?
सर एक बार फिर से ये ब्रीफ में समझा देंगे.
Okay, सबसे पहले
यस सर.
ये फॉरवर्ड बायस एक तरह से. ओके, अगर ये पॉजिटिव है तो होल क्या होंगे? रिपेल.
डिपेंड.
तो एक करंट ये हो गया और यहाँ से इलेक्ट्रॉन क्या होंगे? अट्रैक्ट. ओके, तो करंट किस साइड को होगा इलेक्ट्रॉन का?
एन साइड की तरफ.
इस साइड को होगा ना करंट.
यस सर.
यस
राइट,
सर.
और होल करंट किस साइड को होगा? वो भी इसी साइड को होगा. वो तो इसी को होगा ना, उसमें थोड़ी डायरेक्शन अपोजिट होती है. सो बोथ आर इन दी सेम डायरेक्शन. सो दिस IE इज नथिंग बट दिस I होल प्लस I इलेक्ट्रॉन्स. तो इलेक्ट्रॉन तो माइनॉरिटी करंट है, माइनॉरिटी कैरियर्स है ना यहाँ, एंड होल्स आर
मेजॉरिटी.
मेजॉरिटी. बस तो बन गए. राइट, तो माइनॉरिटी थोड़े कम होते हैं, दैट वी नो. राइट, अब अगर हम आगे भी एक बैटरी लगा देते हैं यहाँ पे, तो दिस इज द नेगेटिव ऑफ द बैटरी, दिस इज द पॉजिटिव ऑफ द बैटरी. तो ये होल्स अगर 100 थे यहाँ मान लो, तो ये दिस इज अ स्मॉल रीजन. तो यहाँ इलेक्ट्रॉन के साथ रिकम्बाइन भी करेंगे कुछ. एक होल रिकम्बाइन हियर with electrons, right? 5% है. So उस चार्ज को पूरा करने के लिए यहाँ से इलेक्ट्रॉन्स जाएंगे अंदर, 5% इलेक्ट्रॉन्स. That is going to contribute towards the IB base. और यहाँ से नेगेटिव मान लो, तो नेगेटिव से नेगेटिव they are going to repel the electrons like this. So IB is going to be opposite to those electrons. अब क्या है कि ये होल्स जो हैं वो यहां जा रहे हैं आगे को, so they are contributing in the, और यहाँ नेगेटिव है, so ये होल्स को अट्रैक्ट करेगा एक तरह से, करेगा.
Yes, sir.
So this is now hole current in this. और दूसरा करंट क्या है, नेगेटिव है. This one. तो ये नेगेटिव है, इट इज गोइंग टू डिटेक्ट होल्स फ्रॉम हियर. ये होल्स इधर आएंगे, ठीक है. तो
Yeah.
ये होल्स आए बेस से, एंड इसके इलेक्ट्रॉन्स को, जो इलेक्ट्रॉन यहाँ माइनॉरिटी कैरियर है, बिकॉज दिस इज नेगेटिव, तो यहाँ मान लो इलेक्ट्रॉन है, तो दिस नेगेटिव इज गोइंग टू रिपेल दीज इलेक्ट्रॉन्स टुवर्ड्स दिस साइड. तो करंट किस साइड होगा,
To the collector.
Collector.
okay. This current is nothing but ICO. ये I इलेक्ट्रॉन्स, तो ये माइनॉरिटी करंट है बेसिकली, राइट.
Yes, sir.
Okay, so this IC is nothing but equal to alpha of IE plus ICO. ठीक है. तो जनरली इसको नेग्लेक्ट कर देते हैं इन करंट्स को, बिकॉज दैट इज इन नैनो एम्पियर्स. तो सीधा सीधा लेना हो तो IC इज इक्वल टू अल्फा IE कर लेते हैं फॉर सिंपल कैलकुलेशंस. अगर इस फॉर्म में दिया होगा तो यू शुड नो दिस आल्सो. This is nothing but this is a leakage current. Because leakage current क्यों है ये, because it is because of the minority carriers. ठीक है. I hope you understand now all the 5 currents.
Yes, sir.
ठीक है.
Yes, sir.
Okay. So this alpha is large signal current gain. Because alpha is nothing but IC by IE. Okay, so this is output current and this is input current. So gain is nothing but output by input always. है ना? So we have gained something, that means how we have gained it. So in case of, because this is common base configuration, active region of the common base configuration, so gain is called as alpha. Okay. Right. तो जैसे इस केस में ऐसे भी निकाल सकते थे ना, IC is equal to alpha IE plus ICO. So alpha is nothing but IC minus ICO divided by IE. So ICO, if we are treating it 0, तो ऐसे भी कर सकते हैं, अदरवाइज ऐसे भी रख सकते हैं. Fine. There is one more factor, that is transport factor. That is beta. Beta is nothing but, that is the ratio of this. Okay, leave it. इसको बाद में करते हैं discuss when we discuss. So this is about the current situation in the common base configuration. If we talk about, ठीक है? So we talk about transistor circuit configuration now. We all know so this is an important topic to understand actually. So ये topic था currents वाला. I hope from this point of view, have you studied ever? Hello. +2 में पढ़ा था इस हिसाब से? नहीं.
No, sir.
No, sir.
No, sir.
No, sir.
Okay. And if we draw the symbol of this transistor, it is like this. This is NPN, and this is PNP. So these are the symbols actually. These are the symbols for transistors. Configurations, there are 3 configurations. So this is base. Sorry. Okay.
एक्सक्यूज
हाँ
मी
जी.
सर, सर होल से मूव कर सकते हैं?
क्या चीज?
सर होल्स.
होल्स हैं क्या बेसिकली? कंडक्शन बैंड भी होती है ना? दिस इज बैलेंस बैंड, दिस इज कंडक्शन बैंड. तो इलेक्ट्रॉन यहाँ भी तो होते हैं. यहाँ से यहाँ चले गए. ओके, से यस और नो, कुछ तो बोलो.
यस सर.
सो बैलेंस बैंड में जो इलेक्ट्रॉन मूवमेंट है वो भी इलेक्ट्रॉन करंट हुआ, और कंडक्शन बैंड में इलेक्ट्रॉन मूवमेंट है तो उसको भी इलेक्ट्रॉन करंट ही बोलना चाहिए ना.
यस सर.
तो पता कैसे लगेगा कि कौन सा इलेक्ट्रॉन करंट है? जैसे आप बोलूंगा मैं जी इलेक्ट्रॉन करंट है, करंट बिकॉज ऑफ द इलेक्ट्रॉन्स, राइट? दोनों केस में ऐसा दिख रहा है ना. तो इसको डिफरेंशिएट करने के लिए होल का कंसेप्ट दिया गया था कि जब इलेक्ट्रॉन की मूवमेंट बैलेंस बैंड में होगी, राइट, होल्स मींस देयर इज अ स्पेस. जैसे बैलेंस बैंड है, अब सिलिकॉन का एटॉमिक नंबर 14 है, 3p2. तो यहाँ 4 स्टेट्स खाली है ना. हेलो,
यस सर.
ठीक है.
ओके सर.
तो ये फर्क है इलेक्ट्रॉन मूवमेंट है. बट उस इलेक्ट्रॉन मूवमेंट को डिफरेंशिएट करने के लिए फिर होल का कंसेप्ट दे दिया ताकि वो अलग अलग हो गए कि हाँ बैलेंस बैंड में जब इलेक्ट्रॉन मूव करेगा तो वो होल करंट है, मूव तो इलेक्ट्रॉन ही करेगा, होल तो ऐसा है ही नहीं कुछ, राइट।
यस सर।
और ये सबसे इंपॉर्टेंट कंसेप्ट है अंडरस्टैंड करने में, क्योंकि यही समझ नहीं आता है सारे लोगों को कि है कि अल्टीमेटली होल। तो किसी को भी डाउट है अभी इस चीज में? हेलो, एनीवन इन द क्लास जिसको ये होल की बात अभी समझ नहीं आ रही हो? Okay, all right. So this is the common base configuration. If I talk about this, so this is emitter, this is base, and this is collector. This is the input side, this is the output side. So what is common in the input and output? It is the base. That's why this configuration is common base configuration of the transistor. और इसी पे ही अभी तक हमने ये डिजाइन बनाया था, ऐसे बनाया था, ऐसे किया था ना। This is emitter, this is base, and this is collector. The base is common to input side, and this is output side. Okay, so that's why it is common base configuration. Then we have this is common emitter, because emitter is common to, ये आपको पता ही है, but I'm just revising it. And then we have common collector. So this is base, this is collector, and this is emitter. So this is common collector configuration. Means collector is common to input and output side, right? So CV, CE, and CC configurations are with us. So working we have seen.
एक्सक्यूज मी सर।
हाँ जी,
सर ये एरो एरो कैसे देते हैं सर? एरो का क्या सिग्निफिकेंस है?
the significance of this arrow, if we talk about, इसके पीछे है the electron movement actually, और this is collector, this is base, and this is emitter. This is N, this is P, and this is N. So sorry, this is NPN. So electron will move towards this side and current is opposite to this direction. Am I right? So this is going to signify the current actually. Okay,
Yes, sir.
right? Okay, now we talk about this characteristics. Common base configuration. Okay, so we are just drawing the symbol here. This is we know, right? So what we do is we are applying certain voltage here, and in order to vary that voltage, we are using a rheostat here. You know rheostat?
Yes, sir.
Yes, sir.
No? So rheostat is variable resistor basically. करंट लगा दिया, यहाँ भी एक करंट सोर्स एमिटर लगा सकते हैं, मतलब we have one another voltage here. उसी चीज को हम अब थोड़ा एक्सपेरिमेंटल वे में कर रहे हैं. This is NPN transistor, we know. Okay, so this is, we know this is current IC, this is current IE. I'll change the color of this. This is current IE is like this. So incoming current is equal to outgoing currents. So two incoming currents, that is equal to outgoing current. Kirchhoff's current law, if you remember. You remember KCL? Okay. At a node क्या होगा? जैसे ये IE है, IC and IB, like this. So this is the situation here above, right? So we'll try to find out two inputs or this. इस केस में भी रियोस्टेट लगा सकते हैं हम यहाँ पे. Like this. This is VCV, this is VVE. Okay. तो इस तरह का एक्सपेरिमेंटल सेटअप रहता है. This is the input side and this is output side actually. अब करेक्टरिस्टिक्स में क्या है, दो तरह की करेक्टरिस्टिक्स है इसके. Sorry, one is input, another one is out. Okay, so input characteristics means varying the input, keeping output constant while keeping the output constant, and यहाँ we are having variation in the output or output voltage, in fact, keeping the input side constant. Input side constant. That is how we define it. If we talk about input characteristics, I'll just take the photograph for faster switches. जल्दी के चक्कर में सब लेट हो रहा है. I'll take one another. Now, if you see it, so these are the characteristics. Okay, I'll make it for you actually. ये ज़्यादा better है. So here what we are wearing is base emitter voltage we are wearing, and it is the emitter current which is varied here. So this is for 0 volt VCV. So this is suppose VCV 1 volt, and this is VCV 6 volts. Okay. Yeah. What we do here is एक तरह से ऐसे. Okay. If this voltage is 0, suppose, means we are not applying any voltage here. So this is nothing but, this is just a, क्या है ये, कुछ नहीं है. This is PN junction only. That's why if you see its characteristics, they are like diode type. Diode की तरह दिख रही है ना?
Yes, sir.
Yes, sir.
है ना? Because we have kept this constant, 0 कर दिया एक तरह से. It is very simple that transistor can be used as a diode also if we take its input characteristics only, means keeping the output side constant. Okay. So अगर 1 volt apply कर दिया मान लो, right? So this, और एक तरह से ऐसे है. एम्पियर की बात करें अगर, sorry, this is like this. Okay, so when we increase this voltage from 0 to 1, suppose, right? So means this positive potential we are increasing. Positive means electrons, they are going to attract towards this side. Okay, am I right? And holes will be moving towards this side. So net current is going towards this side actually. एक तरह से देखो तो current is moving towards this side then. Means it is more helpful in increasing this IE actually. That's why we are getting this IE. It is shifting towards this side as we increase this VCV. Right? So this is the input characteristics of a common base configuration. Similarly, we have the output characteristics. Okay, so output characteristics थोड़ा सा this is IC, this is VCV, keeping the value of IE constant. अगर IE 1 milliampere है, sorry, this is कट ऑफ की, ये कट ऑफ है. तो ICBO कट ऑफ में यूज होगा. माइनॉरिटी करंट, लीकेज करंट ही होगा ना कट ऑफ में. कट ऑफ मीन्स दिस रीजन एक्चुअली, ये रीजन है कट ऑफ. ओके, दिस वन, ये कट ऑफ रीजन है एक तरह से. जैसे ये लाइन आई, तो आई इज 0 हियर एक तरह से. So, this IE is 0 here. जब IE 1 हो जाएगा, this IC भी 1 milliampere के, because IC is nothing but alpha of IE. तो 0.97 milliampere बोल सकते हो, है ना? अगर ये 2 है तो भी approximately 2 ही रहेगा. ये 3 है तो 3 रहेगा. Like this. Okay, so these two currents are almost equal. That input current क्या है? IE, and output current is IC. Both are equal, almost equal. That's why it is used as a constant current source also. A source which will give us constant current. This is where we are applying it. This is the application of common base calculation. Okay? So that's enough for today, I think. Any questions regarding this? Hello?
No, sir.
No, sir.